Hello, are you ready to explore the upper limb? Hi, my name is Rozanne BULAC and I'm from Group 1. We are your reporters for today. Jake, Mae Esabel, Hanah, Leigh, and Jelyssa, Mariz. We will be exploring the pectoral and shoulder regions. Starting off from the overview of the upper limb. Next is the pectoral and scapular regions, the anterior AXIO-APPENDICULAR extrinsic shoulder muscles, the posterior AXIO-APPENDICULAR extrinsic shoulder muscles, and lastly, the scapulohumeral intrinsic shoulder muscles. We will be exploring the importance, the different segments, and the parts of the upper limb. The upper limb is one of the most important parts of our body, for it helps us move our hands in a wide range of directions. Our upper extremities helps us perform our daily activities such as writing, cooking, picking up and grasping things, as well as typing. The upper limb consists of four major segments: the shoulder, arm, forearm, and hand, including clavicle, scapula, clavicle, and scapula. The drawing right here on the left displays the different segments or parts of the upper limb, starting from the arm, then with the forearm, and with the fingers, with the scapula and the clavicle. The shoulder is located in the proximal segment of the limb that overlaps parts of the trunk, which is the thorax and back, and lower lateral neck. The arm is located in the first segment of the free upper limb, more mobile part of the upper limb, dependent of the trunk, and the longest segment of the limb. It extends between and connects the shoulder and the elbow, and consists of anterior and posterior regions of arm, centered around the humerus. The forearm is the second longest segment of the limb. It includes anterior and posterior regions of the forearm, overlying the radius and ulna. The hand is in the upper part, of the limb distal to the forearm that is formed around the carpus, metacarpus, and phalanges. It is composed of the wrist, palm, dorsum of hand, and digits or fingers, including an opposable thumb, and is richly supplied with sensory endings for touch, pain, and temperature. The clavicle, right here, the drawing of the clavicle connects the upper limb to the trunk. Also, it is also called as the collarbone. It supports the scapula. It transmits the weight and forces from the upper limb to the body trunk. It serves as a movable crane-like strut for rigid support, from which the scapula and free limb are suspended, keeping them away from the trunk so that the limb has maximum freedom of motion. Lastly, it transmits shocks or traumatic impacts from the upper limb to the exoskeleton. The drawing right here displays the scapula, or as we can call the shoulder blade. It is a triangular flat bone that lies on the posterolateral aspect of the thorax, overlying the 2nd to 7th ribs. This structure allows an individual perform movements such as protraction, retraction, elevation, depression, upward motion, rotation, and downward rotation. Let's proceed to the next topic. Under the pectoral and scapular regions, we're going to explore the importance, the description, and these sub-regions. The pectoral and scapular regions are the muscles in the shoulder that helps attach the appendicular skeleton of the upper limb to the axial skeleton of the trunk. It can be found based on their location, which are grouped into anterior AXIO-APPENDICULAR or thoraco-appendicular or pectoral muscles, the posterior AXIO-APPENDICULAR, and the scapulohumeral muscles. Now, let us dig deeper in the anterior AXIO-APPENDICULAR extrinsic shoulder muscles. This right here, the drawing shows the pectoralis major and the pectoralis minor. We will see that again later. The anterior AXIO-APPENDICULAR muscles has 4 muscles: the pectoralis major, pectoralis minor, subclavius, and serratus anterior. The pectoralis major is a large, fan-shaped muscle that covers the superior part of the thorax. It has a clavicular and sternocostal heads. The sternocostal head is much larger, and its lateral border forms the muscular mass that makes up most of the anterior wall of the axilla. The pectoralis minor, on the other hand, lies in the anterior wall of the axilla, where it is almost completely covered by the much larger pectoralis major. The subclavius and the serratus anterior. The subclavius lies in the anterior wall of the axilla, where it is almost the subclavius lies almost horizontally when the arm is in the anatomical position. This small round muscle is located inferior to the clavicle. It affords some protection to the subclavian vessels and the superior trunk of the brachial plexus if the clavicle fractures. It also helps resist the tendency for the clavicle to dislocate at the sternoclavicular joint, like for example when pulling hard during a tug of war. The subclavius helps resist the tendency to dislocate of the arms. The dislocation of the arms. The serratus anterior overlies the lateral part of the thorax and forms the medial wall of the axilla. This broad sheet of thick muscle was named because of the saw-toothed appearance of its fleshy slips or digitations. The serratus anterior is one of the most powerful muscles of the pectoral girdle. It is a strong protractor of the scapula and is used when punching or reaching anteriorly, sometimes called the boxer's muscle. Now you know. Now, let us proceed to the posterior AXIO-APPENDICULAR muscles. Posterior AXIO-APPENDICULAR muscles has superficial intermediate groups of extrinsic back muscles. It is attached to the superior appendicular skeleton of the upper limb to the axial skeleton in the trunk. It has 2 subgroups: the superficial posterior AXIO-APPENDICULAR extrinsic shoulder muscles and the deep posterior AXIO-APPENDICULAR extrinsic muscles. For the superficial AXIO-APPENDICULAR extrinsic muscles, we have the trapezius. Trapezius provides a direct attachment of the pectoral girdle to the trunk. This large triangular muscle covers the posterior aspect of the neck and the superior half of the trunk. The latissimus dorsi, or the widest of the back, was well chosen because this muscle covers a wide area of the back. This latissimus dorsi extends, retracts, and rotates the humerus medially, like when you fold your hand behind your back or scratch the skin over the opposite scapula. So let's look at the drawing again. That's trapezius, we can see it. It is a trapezoid shape. Also, the levator scapulae, the latissimus dorsi, you can see that is very wide. It covers like 1/4 of our backs. For the deep posterior appendicular extrinsic shoulder muscles, we have the levator scapulae, which is the superior third of the strap-like levator scapula lies deep to the sternocleidomastoid. The inferior third is deep to the trapezius. True to its name, the levator scapulae acts with the descending part of the trapezius to elevate the scapula or fix it. Sometimes it resists forces that would depress it, like when you carry a load. The rhomboids, major and minor, which are not always clearly separated from each other, have a rhomboid appearance. That is, they form an oblique equilateral parallelogram. Let's move on to scapulohumeral intrinsic shoulder muscles, our very last topic until the next reporter. The scapulohumeral intrinsic shoulder muscles originate from the scapula and or clavicle and attached to the humerus. It has 3 muscle groups, which we will explore the 2 of them. And for the rotator cuff muscles, Jake will lead us. For the deltoid is a thick, powerful, coarse textured muscle covering the shoulder and forming its rounded contour. You can see that deltoid is right over here. It has the biggest space. As its name indicates, the deltoid is shaped like the inverted Greek letter delta. The anterior and posterior parts act like guy ropes to steady the arm as it is abducted. The teres major also is a rounded muscle. It passes laterally from the infralateral third of the scapula. It adducts and medially rotates the arm. It can also help extend it from the flex position and is an important stabilizer of the humeral head in the glenoid cavity. That is, it steadies the head in its socket. That's the end of our discussion. And now let's proceed for the rotator cuff muscles. Jake will explain. Thank you for listening. Thank you for listening.
So, hi, I'm Jake ALBUTRA and I am one of the reporter in upper limbs, and the topic we will tackle is compartments, muscles, and arteries of the forearm. Forearm extends from the elbow joint to the hand and it is made up of ulna and radius bones. The forearm is the region of the body spanning from the elbow to the wrist. It consists of several muscles and an extensive neurovascular network encased in 3 compartments. These include the anterior compartment, posterior compartment, and the mobile wad. The compartments of the forearm are separated by interosseous membrane found between the radius and ulna in addition to a lateral intermuscular septum. The muscles found in the posterior compartment primarily function to extend the wrist and digits. The muscles are further broken down into deep and superficial groups. The superficial group includes the extensor digitorum communis, extensor digiti minimi, extensor carpi ulnaris, and anconis. The deep group includes the supinator, abductor pollicis longus, extensor pollicis brevis, extensor pollicis longus, and extensor indicia. The mobile wad consists of 3 muscles, the brachioradialis, extensor carpi radialis longus, and extensor carpi radialis brevis. The anterior compartment contains muscles that act to flex the wrist and digits. The muscles are separated into deep intermediate, and superficial groups. The superficial compartment contains the pronator teres, the flexor carpi radialis, and the flexor carpi ulnaris. The intermediate compartment contains the flexor digitorum superficially. The deep compartment of the contains flexor digitorum profundus, flexor pollicis longus, and pronator quadratus. The primary function of these muscles is digit and wrist extension, with the extensor carpi ulnaris assisting in ulnar deviation of the wrist during wrist extension. The deep group contains the supinator, abductor pollicis longus, extensor pollicis brevis, and extensor pollicis longus. The supinator functions to supinate the forearm. The posterior compartment of the forearm is also known as the extensor compartment since the muscles primarily function to extend the wrist and digits of the hand. The posterior compartment of the forearm contains a superficial and deep muscle group. The superficial group includes the extensor digitorum communis, extensor digiti minimi, extensor carpi ulnaris, and anconeus. These muscles are relatively subcutaneous as there is usually not much subcutaneous fat on the dorsal aspect of the forearm. Supination is defined as the radius rotating laterally around its longitudinal axis over the ulna, causing the palm to face anteriorly. Similarly, the tendon of the extensor digiti minimi of the superficial posterior compartment travels ulnar to the extensor digitorum tendon, the small finger, and assists in small finger extension. Let's move on to the next topic, which is the muscles of the forearm. The forearm is the portion of the arm distal to the elbow and proximal to the wrist. Two bones, the radius laterally and the ulna medially, form the forearm. It has two compartments, the anterior, which is the flexor, and the posterior, which is the extensor. The two compartments together have 17 muscles in total. Here, we will discuss the anterior compartment of the forearm in the setting of their attachment points, function, innervation, and vascular supply while providing clinical examples to reinforce this information. When identifying the function of the forearm muscles, it is important to note that any forearm compartment muscle that crosses the elbow joint will act at this joint, because the contribution of each forearm muscle to elbow movement is small. Muscles of the forearm or antebrachium work together to move the elbow, forearm, wrist, and digits of the hand. They fall into two categories, intrinsic and extrinsic muscles. The intrinsic muscles function to move the forearm by pronating and supinating the radius and ulna. The extrinsic muscles, on the other hand, flex and extend the digits of the hand. One muscle, the brachioradialis, traverses the elbow joint running from the arm to the wrist, helping to flex the elbow. So the last one we will tackle is the arteries of the forearm. What are the arteries found in the forearm? The ulnar, radial, and anterior and posterior interosseous arteries. Courses down the forearm, they branch into dorsal and palmar carpal arteries that supply the wrist and deep and superficial palmar branches that supply the hand. As the brachial artery runs down the arm and passes through the elbow, it divides into two terminal branches, the radial artery and the ulnar artery. These two arteries provide the blood supply for the entire forearm and hand. The radial artery gives off the recurrent radial branch just distal to the radial head and traverses back up to the arm, form an anastomosis with the radial collateral of the deep brachial artery. The recurrent radial branch provides the blood to the supinator and the brachioradialis muscle. The radial artery then continues down to the forearm to the wrist, where it wraps posteriorly before diving into the hand. Similarly, the ulnar artery gives off two recurrent branches, the anterior and posterior. As it passes the elbow, these two turn upward and create anastomosis with the inferior and superior collateral arteries that branch off the deep brachial artery. The anterior ulnar recurrent artery provides blood to the pronator teres and brachialis, while the posterior ulnar recurrent artery provides blood supply to the proximal portions of the flexor muscles, bones, and elbow joint. After giving off the recurrent branches, the ulnar artery gives rise to the common interosseous branch, which will continue to divide like into the anterior and posterior interosseous arteries. The names of these arteries denote which side of the interosseous membrane they run on. The anterior interosseous branch supplies blood to the muscles of the flexor compartment. As it travels down to the forearm, it will eventually pierce to the interosseous membrane and anastomose with the posterior interosseous artery, which is the blood supply for the extensor compartment of the forearm. So that's the end of my discussion, and let's move on to the next topic.
Muscle of the arm. The anconeus, a distal triceps helper, is similarly located in the posterior compartment. In all situations, the anterior compartment flexor muscles are nearly twice as powerful as the extensors. As a result, we are better pullers than pushers. Of the four major arm muscles, three flexor in the anterior flexor compartment are biceps, brachii, brachialis, coracobrachialis, and one extensor is in the posterior compartment supplied by radial nerve, the triceps brachii. The biceps brachii or biceps is a muscle that is found in the anterior compartment of the arm. It may generate motion in the glenohumeral, elbow, and radioulnar, and it functions across three joints. The biceps consist of two heads, the long and short head, which they are raised proximally and joined to attach to the radius as biceps tendon, and they both originate from the scapula. Long head originates at the supraglenoid tubercle above the glenoid cavity of the scapula. It lies within intracapsular space, but it still remains extra-synovial. The short head arises at the apex of the coracoid process of the scapula, where it partly blends with the origin tendon of the coracobrachialis. Brachialis and coracobrachialis. Brachialis is an upper arm muscle that flexes the elbow. It is deeper than the biceps brachii and makes up part of the floor of the cubital fossa region, or elbow pit. The brachialis generates around 50% or more power than the biceps when it comes to elbow flexion. The brachialis is a muscle of the forearm that flexes the forearm at the elbow. It is also capable of both pronation and supination, depending on the position of the forearm. The coracobrachialis is a long, slender muscle located in the arm's anterior compartment. It runs from the coracoid process of the scapula to the shaft of the humerus. The coracobrachialis muscle's primary purpose is to induce flexion and adduction of the arm at the shoulder joint. The coracobrachialis is a relatively long muscle that is located in the shoulder joint. The name coracobrachialis is a reference to these muscles' point of origin and insertion. This muscle originates from the coracoid process of the scapula, or shoulder blade, which is a hook-shaped bony prominence at the top outer part of the scapula. What is unique about brachialis? The brachialis is one of the largest elbow flexor and provides pure flexion of the forearm at the elbow. It does not provide any supination or pronation of the forearm. The function of the brachialis is to flex your elbow, especially when your forearm is in the pronated or palm down position. It has large cross-sectional area and is able to produce more strength than the biceps brachii. The triceps brachii. The triceps brachii is a muscle that goes from the back of the humerus, which is the upper arm's long bone, to the top of the ulna, which is the forearm's long bone. The triceps brachii gets its name because it contains three muscle heads or points of origin. These include the medial head, the lateral head, and the long head. The triceps brachii also helps to stabilize the shoulder by keeping the head of the humerus in its correct position in the shoulder joint. The region of long head, infraglenoid tubercle of the scapula, the region of lateral head is the lateral and posterior surfaces of the humerus above the radial groove and lateral intermuscular septum. The region of medial head, posterior surface of the humerus below the radial groove and from the medial intermuscular septum. Cubital fossa. The cubital fossa is a triangular space located anterior to the elbow joint. It is an area of transition between the anatomical arm and forearm, which several important structures transverse through. The cubital fossa is seen superficially as a depression on the anterior aspect of the elbow. Deeply, it is a space filled with a variable amount of fat anterior to the most distal part of the humerus and the elbow joint. The three boundaries of the triangular cubital fossa are the medial border, lateral border, and superior border. The medial border of the cubital fossa is formed by the pronator teres muscle, which originates from the medial epicondyle. This muscle is innervated by the median nerve and is located in the anterior compartment of the forearm. The lateral border. The lateral border of the cubital fossa is formed by the brachioradialis, which originates from the lateral supraepicondylar ridge of the humerus. These muscles is innervated by the radial nerve, as it located in the posterior compartment of the forearm. Lastly, the superior border. The superior border of the cubital fossa, which forms from the base of the triangle, is marked by an imaginary transverse line drawn between the medial and lateral epicondyles of the humerus. The forearm. The forearm is the distal unit of the articulate strut of the upper limb. It extends from the elbow to the wrist and contains two bones, the radius and ulna, which are joined by an interosseous. Although thin, this fibrous membrane is strong, in addition to firmly tying the forearm bones together while permitting pronation and supination. The interosseous membrane provides the proximal attachment for some deep forearm muscles. The head of the ulna is at distal end of the forearm, whereas the head of the radius is at its proximal end. The role of forearm movement occurring at the elbow and regional joints is to assist the shoulder in the application of force and in controlling the placement of the hand in space. How many parts make up the forearm? Two bones, the radius laterally and the ulna medially, forms the forearm. It has two compartments, the anterior flexor and the posterior extensor. The two compartments together have 20 muscles. The ulna and radius. The ulna is located on the medial side of the forearm and the radius is on the lateral side. These bones are attached to each other by an interosseous membrane. More distal is the shaft of the ulna. The small rounded area that forms the distal end is the head of the ulna. Muscles of the forearm. There are 17 muscles crossing the elbow joint, some of which act on the elbow joint exclusively, whereas others act at the wrist and fingers. In the proximal part of the forearm, the muscles form fleshy masses extending inferiorly from the medial and lateral epicondyles of the humerus. The tendons of these muscles pass through the distal part of the forearm and continue into the wrists, hand, and fingers. The flexor muscles of the anterior compartment have approximately twice the bulk and strength of the extensor muscle of the posterior compartment. The superficial compartment of the flexor surface of the forearm contains pronator teres, the flexor carpi radialis longus, the palmaris longus, the flexor carpi ulnaris, and the flexor digitorum superficialis. All of these muscles originate primarily from the medial epicondyle of the humerus. The final attachment site for the pronator teres is the middle portion of the radius. Both the flexor carpi radialis and the flexor carpi ulnaris insert on the base of the second and fifth metacarpals respectively. The flexor digitorum superficialis crosses the wrist through the carpal tunnel and inserts at the proximal interphalangeal joint at the base of the middle phalanx of digits 2 through 5. What is muscle of the forearm? The superficial compartment of the flexor surface of the forearm contains pronator teres, the flexor carpi radialis, longus palmaris, the flexor carpi ulnaris, and the flexor digitorum superficialis. And that's all. Thank you.
Did you know that the hands, including the wrists, are the body parts with the most bones in the body? With each hand having 27 bones, making it a total of 54 bones together. That's over 25% of the total bones in the human body. If you already knew that little trivia, then keep on watching to learn more about the fascinating outworkings of the wrist. And if not, that is totally okay, and may this serve as your learning for today. Hello, and my name is Hanah ABELLA, and I will be teaching you everything you need to know about the wrist and intercarpal joints. May you be as excited as learning about anatomy as I am teaching you. Thank you.
So at this point, we shall dive into our topic, that is the wrist joint. Its key takeaways include but are not limited to the following: articulation, joint capsule, ligaments, and movements. So the wrist joint or the radiocarpal joint is essentially a condyloid type of synovial joint. A synovial joint is a joint which moves against other joints. So in other words, the wrist joint is a joint that is attached or articulates with the carpal bones. The head of the ulna is separated from the carpal bones by the strong triangular fibrocartilaginous ligament called the articular disc, which separates the wrist joint from the distal radio-ulnar joint. The joint is stabilized by the strong medial and lateral ligaments. The position of the joint is indicated approximately by a line joining the styloid process of the radius and ulna, or by the proximal wrist crease. The wrist, or the carpus, the proximal segment of the hand, is a complex of 8 carpal bones articulating proximally with the forearm by the wrist joint and distally with the 5 metacarpal joints. So for the key takeaways, we have the articulation of the wrist joint, that is between the distal end of the radius and the articulating surface of the scaphoid, lunate, and triquetral bones. So as mentioned, the ulna is not a part of the wrist, but is rather prevented from articulating with the carpal bones by a ligament called the articular disc, which lies over the superior surface of the ulna. Its purpose is to stabilize the joint and to allow for more movement for the wrist. So like any other synovial joint, its capsule is dual-layered. The capsule encloses the joint, and its outer layer is attached above the distal ends of the radius and ulna and below the proximal row of carpal bones. The internal layer is composed of a synovial membrane that secretes a lubricating fluid called the synovial fluid. So in this cavity or space right here, we can see that the ulna is not attached to the carpal bones, and this cavity is filled by the articulating disc and all the other medial ligaments that line the wrist. So anterior and posterior ligaments strengthen the capsule. The medial ligament is attached to the styloid process of the ulna and to the triquetral bone, and the lateral ligament is attached to the styloid process of the radius and to the scaphoid bone. The synovial membrane lines the capsule and is attached to the margins of the articular surfaces. The joint cavity does not communicate with that of the distal radioulnar joint or with the joint cavities of the intercarpal joints. The wrist joints are innervated by the anterior interosseous nerve and the deep branch of the radial nerve. So finally, for the movements of the wrist are flexion, extension, abduction, adduction, and circumduction. Rotation is not possible because the articular surfaces are ellipsoid shaped, but the lack of rotation is compensated for by the movement of pronation and supination of the forearm. So for your reference, we have here a close-up look of the wrist joint and its carpal bones. Here we can see the radius and the ulna, the lunate, the pisiform, capitate, hamate, trapezoid, trapezium, and the scaphoid. Another illustration right here are the palmar surface of the hand and with the wrist bones. So we could say that this is the right hand because the radius is right here and the ulna is right here. So the radius of the hand is always on the lateral end and the ulna on the medial end. So the movements, the flexion is performed by the flexor carpi radialis, the flexor carpi ulnaris, and the palmaris longus. Extension is performed by the extensor carpi radialis longus, the extensor carpi radialis brevis, and the extensor carpi ulnaris. Abduction is performed by the flexor carpi radialis and the extensor carpi radialis longus and brevis. Adduction is performed by the flexor and extensor carpi ulnaris. Because the styloid process of the radius is longer than that of the ulna, abduction of the wrist joint is less extensive than adduction. In flexion-extension movements, the hand can be flexed about 80 degrees but extended to only 45 degrees. The range of flexion is increased by movement at the mid-carpal joint. To sum up the lesson for today, we could say that the wrist joint is a synovial joint between the distal end of the radius and the proximal row of carpal bones, and it articulates between the distal end of the radius and the articulating surface of the scaphoid, lunate, and triquetral bones. Its movements are flexion, extension, abduction, adduction, and circumduction only, without the rotation. It is innervated by the anterior interosseous nerve and the deep branch of the radial nerve. So, thank you for listening and see you on the next topic, the intercarpal joints. So the intercarpal joints, or the joints of the hands and fingers, are pretty straightforward and quite simple. The intercarpal joints are the synovial plane joints that connect the carpal bones, and they gather at the set of joints that follow. The joints of the proximal carpal row that connect the adjacent surfaces of the scaphoid, lunate, and triquetrum bones. The joints of the distal carpal row via which the adjacent surface of the trapezium, trapezoid, capitate, and hamate bones articulate, mid-carpal joint by which the carpal rows articulate with each other, and the piso-triquetral joint formed by the articulation of the pisiform with the palmar surface of the triquetrum. The joints of the proximal and distal carpal rows are supported and fixed by many ligaments, so there is minimal movement within them. Their function is to coordinate the movements of the wrist or the radiocarpal and midcarpal joints. The midcarpal joint, however, is able to produce a noticeable range of motion organized into 2 degrees of freedom, and that is flexion, extension, and abduction, adduction. Now for the key takeaways of the intercarpal joints, we have the articulation. It is between the individual bones of the proximal row of the carpus, between the individual bones of the distal row of the carpus, and finally in the midcarpal joint, between the proximal and distal rows of the carpal bones. So intercarpal means between the carpal bones. So the intercarpal joints are represented with the gray spaces right here, and we can see where they articulate. So we have already identified the type of joint the intercarpal joints are, and that is synovial plane joints. Its capsule is a capsule that surrounds each joint, and the purpose of this is to enclose the joint to produce a smoother movement between the joints. The ligaments are the bones that are united by strong anterior-posterior interosseous ligaments. The interosseous ligaments are proximal and distal carpal rows, palmar intercarpal, dorsal intercarpal ligaments. The synovial membrane lines the capsule and is attached to the margins of the articular surfaces, and the intercarpal joints are innervated by the anterior interosseous nerve, deep branch of the radial nerve, and deep branch of the ulnar nerve. It receives its blood supply from the palmar and dorsal carpal arches. So we could recall that the intercarpal joint is a biaxial joint, therefore it could move into 2 degrees of freedom. The flexion, extension, abduction, adduction. And circumduction is also possible as a combination of the above movements. The range of motion of flexion is 35 degrees and extension 50 degrees. Adduction, on the other hand, is 8 degrees and adduction 15 degrees. The movements of the intercarpal and midcarpal joints follow the movements of the radiocarpal joints and are usually described together with them. Concerning that the ligamentous apparatus of the carpus strongly binds the bones together, there isn't much movement at the proximal and distal intercarpal joints. The proximal intercarpal joints allow noticeable flexion and extension, while the distal joints move significantly less. Instead, these movements are important for adjusting the shape of the hand, while the movements on the radiocarpal and midcarpal joints occur. So that is it for the intercarpal joints. So to summarize, it is a synovial plane joint. It articulates on the proximal row, adjacent articular surfaces of the scaphoid, lunate, and triquetrum bones, joints of the distal carpal row, adjacent articular surfaces of trapezium, trapezoid, capitate, and hamate bones, and the midcarpal joint, the distal articular surfaces of the proximal carpal bones. And the ligaments are interosseous ligaments of proximal and distal carpal rows, palmar intercarpal, dorsal intercarpal ligaments, and it is innervated by the anterior interosseous nerve, posterior interosseous nerve, and deep and dorsal branches of ulnar nerve. Thank you for listening.
Hello, my name is Jelyssa, and right now we are going to discuss about the metacarpophalangeal joints, and under it we have articulations, movements, ligaments, and many more, but I didn't write down everything because it might not fit, but as we move along you will get to know the others. So let's continue. So what is the meaning of the metacarpophalangeal joints? Metacarpophalangeal joints, or MCP, are a collection of condyloid joints that connect the metacarpus or the palm of the hand to the fingers. There are 5 separate metacarpophalangeal joints that connect each metacarpal bone to the corresponding proximal phalanx of each finger. Let's go over the subtopics of the metacarpophalangeal joints. So we have the articulation, the type, the capsule, the ligaments, synovial membrane, and movements. So articulation between the heads of the metacarpal bones and the bases of the proximal phalanges. The type is synovial condyloid joints. The capsule surrounds the joint. The ligaments, the palmar ligaments, are strong and contain some fibrocartilage. The deep transverse metacarpal ligaments unite the 2nd, 3rd, 4th, and 5th joints, which holds the heads of the metacarpal bones together. Each pass downward and forward from the head of the metacarpal bone to the base of the phalanx. The collateral ligaments are taut and when the joint is in flexion, and lax when the joint is in extension. Synovial membrane. This lines the capsule and is attached to the margins of the articular surfaces. The movements, we have flexion, extension, adduction, and abduction. We have 4 movements. So we have flexion, lumbricals, and interosseous. Extension is extensor digitorum, extensor indicis, and extensor digiti minimi. Next is adduction and abduction. They are both performed by the dorsal interossae. For the joint of the thumb, we have flexion, flexor and pollicis, longus and brevis. For extension is an extensor pollicis, longus and brevis. Adduction and abduction are both performed at the carpo-metacarpal joint. About the metacarpophalangeal joint. So metacarpal heads articulate with much smaller concave articular facets located on the bases of the proximal phalanges. The facets of the phalanges are elongated anteriorly by the palmar ligament that functions as a hinge. In summary, what are metacarpophalangeal joints? They are a collection of condyloid joints that connect the metacarpus or palm of the head to the fingers. Collateral ligaments are cord-like bonds present on each side of the joints. Movements are flexion, extension, adduction, and abduction, and the type is synovial joint. Next, we have interphalangeal joints, movements, meaning, and facts. After learning about the metacarpophalangeal joints, let's move on to the interphalangeal joints. We have the movements, the meaning, and the facts. Starting to lose my voice, so please bear with me. So what is the meaning of the interphalangeal joints? They are synovial hinged joints that have a structure similar to that of the metacarpophalangeal joints. The arrangement of these ligaments is similar to those in the metacarpophalangeal articulations. The extensor tendons supply the place of the posterior ligaments. Each interphalangeal joint is composed of the head of the more proximal phalanx and the base of its distal counterpart. So there are two sets of interphalangeal joints. This excludes the interphalangeal joints of the thumb. So we have proximal interphalangeal joints and distal interphalangeal joints. So for proximal interphalangeal joints are those between the first and the second phalanges. So the first is also known as a proximal, while the second is intermediate. Now, second is the distal interphalangeal joints, those between the second and the third phalanges. The third is also known as the distal. There are two movements permitted in the interphalangeal joints. These are the flexion and extension. These movements are more extensive between the first and second phalanges. The amount of flexion is very considerable, but extension is limited by the volar and collateral ligaments. Flexion of the interphalangeal joints of the fingers is accomplished by the flexor digitorum profundus, acting on the proximal and distal joints, and by the flexor digitorum sublimes, acting on the proximal joints. Extension is affected mainly by the lumbricals and interossi, the long extensors having little or no action upon these joints. So in addition to the movements that I've said before, so we have flexion and extension of the interphalangeal joints of the thumbs. So for flexion, it is accomplished by the flexor pollicis longus, while for extension, it is accomplished by the extensor pollicis longus. Next, we have fun facts. The interphalangeal joints of the foot are articulations between the phalanges of the toes. In the toes, 2 to 5 a proximal and distal set of interphalangeal joints is present. So to sum up everything, there are two permitted movements in the interphalangeal joints. So we have flexion and extension. Proximal interphalangeal joints are those between the first and second phalanges. Distal interphalangeal joints are those between the second and third phalanges. They are synovial hinge joints that have a structure similar to that of the metacarpophalangeal joints.